Hello, welcome in the CHAISE Erasmus Plus project, Module 2, Regulation, Legal Aspects and Governance of Blockchain Systems. In this third lecture, we define the blockchain ecosystem, identify the actors and the way they interact in a blockchain system. This lecture has been prepared by Frédéric Bienier in Salion, l'Iris Lab, France. This lecture on blockchain ecosystem has been designed to make you be able to describe blockchain-related legal environment in Europe and the world and explain the implications of blockchain technology for government, policymakers, law professionals, regulators, and society, as knowing more precisely as the blockchain ecosystem is designed and organized is a key issue for these skills. After this lecture, this will also allow you to take responsibility when deciding about the blockchain, cryptocurrencies and use of smart contracts by a better understanding of the ecosystem and also to participate in discussion regarding blockchain technology impact and blockchain governance decision. These skills are based on some knowledge related to the blockchain-related legal environment, to the legal underpinnings of blockchain technology and smart contracts, and to the implications of blockchain technology for society, regulators, policymakers, governments, and law professionals, by knowing more precisely the way the ecosystem is organized and the key challenges. So, capturing an ecosystem organization is not so obvious. According to your best knowledge, can you define precisely what ecosystem means and how an ecosystem can be characterized? Is there one or different kinds of blockchain ecosystems? How can we identify a blockchain ecosystem? Who are the key actors? How do these actors interact with their environment? How are they organized? How do they manage value? How can you identify a blockchain ecosystem? All these questions and their answers are not too simple. Let's think and brainstorm regarding these questions. Ecosystem. Does it refer to economy, to ecology? What is the important part in case of blockchain ecosystem? What is a system? Is it a single dimension? Multiple dimensions? How can you characterize such a system? Combining eco and system. What does it mean exactly? How can you characterize it? According to your best knowledge, how can you define a blockchain? Who participate in a blockchain project? Are roles similar? Are there different kinds of actors? Are there different kinds of blockchain systems? Think on what we said in lecture 1. What are the key axes to define the blockchain typology? Is a permissioned blockchain different from a permissionless blockchain system? Are there different kinds of actors? Are organizations different? So, what is in a blockchain ecosystem? What is outside the blockchain ecosystem? Which kind of actors? Why? So, with these few questions, you can see that it's not so obvious. So this lecture will provide you the necessary knowledge to characterize an ecosystem, to identify the main characteristics of a blockchain ecosystem before introducing some usage-based blockchain ecosystems characteristics. To sum up, this lecture addresses different learning objectives regarding the ecosystems. We are going to identify key concepts, characterize the ecosystem boundaries, the structure, and the different kinds of interactions. Then we will focus on the blockchain ecosystems, paying attention to the blockchain context, to the ecosystem structure, key actors definition. And lastly, we are going to consider the blockchain as a usage-based ecosystem. So we will learn how usages can be characterized and provide concrete examples of blockchain ecosystem models. So, based on these learning objectives, this lecture is organized in 3 main parts. The introduction of ecosystems is designed to identify key concepts and organizations based on the system theory, leading to formalize ecosystems characteristics to support their descriptions. This is a generic part. Then we will focus on the blockchain. The second part, on blockchain ecosystem, will allow describing them by identifying key characteristics based on this generic ecosystem description picked from part 1, before introducing the typology of the main actors involved in the blockchain ecosystem. Lastly, in the usage-based blockchain ecosystem part, we will identify first the way usages can be characterized so that the constant evolution can be captured before proposing some illustrations focused on some current blockchain ecosystem. So, first of all, let's define what ecosystem means. Ecosystem, we can identify that there are 2 parts in this word, eco plus system. A system may be understood according to the system theory. It has a group of independent and interacting components that forms a complex whole. Eco may stand for ecology or economy. Most of ecosystems are defined based on the ecology, defining interactions between entities and living entities, of course. If we pick the basic definition from dictionaries, namely Cambridge or Collins, both of them bring to light few points. An ecosystem is a complex object consisting of different components that may be living components or not. It must be considered as a dynamic system. Components live or work together, leading to interactions between them and between components and their environment. The ecosystem refers also to complex systems which behaviors take advantage of the synergy issued from components interaction. To sum up, there's no real differences according to the system definition from the ecology and the economy side of eco. It means that components are interacting and must be seen as a dynamic part of the system, either because they are living or because they are working together. This basic definition shows that an ecosystem is a special kind of system which includes living components or a set of business activities. This is quite close to the systems theory and the system science. So defining an ecosystem involves thus defining precisely the system by setting clear boundaries, the global structure including the different components, and what the system does, it has its purpose. Let's take an example. Here, you've got a collaborative manufacturing ecosystem. Okay, components are members of a supply chain. The boundaries is associated to the limit, the clear limit of the supply chain. Client or material supplier or bank doesn't belong to this ecosystem, but producers, resellers, logistic companies, transportation systems are parts of the ecosystem. So we can identify clearly the ecosystem boundaries. Focusing on the IT side, a system associated to an information system hosted on an external infrastructure as a service platform includes only software components, and the infrastructure belongs to the environment, whereas both software and hardware belongs to the system if the infrastructure is not outsourced. By defining these boundaries, we can capture the way the system interacts with its environment. In our supply chain example, client sends order and gets some delivery from the supply chain system. The producer have some orders and get some delivery and make some payment to interact with the material supplier and the bank. So now we can identify the global boundaries of the system. But how does it work inside? Inside, we can find a global structure which includes the different components. For example, an information systems include both human components, namely people in charge of manual processes, and IT components, such as database, software components, network infrastructure, and so on. Each of these components can be described recursively as a system including sub-components. Let's now go back also to our supply chain example. In our supply chain ecosystem, we got some resellers, some producers, some logistics actors. A producer, a manufacturer can be seen as a set of subsystems, namely some production lines, some supply management, some customer relationship management entities, and so on. So now, how can we define the system? The system is defined mostly regarding what it provides, its purpose, its functioning. So to sum up, a system has a structure in charge of different activities to meet the purposes for which it has been designed. An ecosystem consists in autonomous living components or business activities interacting together. But how can we capture this dynamic behavior in the system organization? Based on the system characteristics, modules are set describing the system according to different points of view. Modules can describe the system's static organization and properties, the information it manages, decision and control processes associated to its behavior. This leads to different models, for example, data models, process models, decision models, control models. Interactions between components or with the environment are also described by the modules. Characterizing these interactions leads to describe information, material, decision flows between components or between the system and its environment. Interaction with the environment allows capturing external information and material as inputs to the system and provide material or information as output of the system. Such a description is quite close to control theory, but of course, inputs and outputs may be more complex. So now let's focus on a special kind of ecosystem, the business ecosystem. As stated in the basic definition, a business ecosystem relies on a business community in charge of business activities and working together. This leads to identify first the business purpose related to the business activities achieved by the community. In my previous example, for example, the supply chain has been designed to provide some special kinds of products. But how can we describe these activities and their purposes? Is the supply chain only limited to the product delivery? For short, business means buying or selling a product or service. We can identify the ecosystem purpose by identifying the kind of product or service it produces. It means that either the community members will produce the same kind of product or service, share common regulation rules, reference knowledge, or that they will contribute to the production of a kind of product or service. The ecosystem community, which can be used to draw the business ecosystem boundaries, gather multiple parties working to meet the common purpose. Focusing on the way the ecosystem or community is structured, we can identify different kinds of organizations. First, the business community can be associated to a business area. In such case, it gathers independent organizations that are linked thanks to their business activity field, sharing a common knowledge and know-how. Organizations may cooperate according to a one-shot peer-to-peer interaction. For example, a simple order. In such case, there are no real interaction between members of the community. Each of them defines its own process, fitting the business field regulation rules according to its own value chain. Consequently, the global ecosystem does not take advantage of the community synergy. Second, a business community can be organized as in a decentralized way, gathering different partners of the same stakeholder. Such a community is structured hierarchically, as each member of the community can also develop its own ecosystem, gathering its own hierarchical dependent partners. Interaction between community members are directed by the hierarchical organization following the main stakeholder value chain. Supply chain can be seen as an example of such business ecosystem, where the main stakeholder defines its first partners and then each partner can define its own supply chain, gathering its own ecosystem to achieve the task it has to do. Lastly, collaborative networked organization denotes a community where each member may collaborate with others, taking advantage of the networked value chain. Such community organization requires important coordination between two or more parties while working on the common activities. This leads to a distributed decision organization, and it improves the global synergy in a win-win vision. The business ecosystem also interacts with its environment by providing the product and service associated to its purpose. Of course, these interactions can be associated to the value they carry. This leads to new questions. How can we define and measure value? Is there a unique and universal value, or does value require more complex definition? Regarding a simple production system, value may be defined as the financial value associated to the price or the added value of the product service. It may also be defined according to the social impact, the usefulness of the service or the product, the environmental impact, providing the environmental benefit or consuming environmental resources. It may also have cultural impact. Let's take an example from the blockchain field. Creating a non-fungible token transaction can be associated to the financial value of the transaction. The proof of work block validation has also an environmental impact due to the energy consumption, whereas the non-fungible token development impacts the artistic creation. It may also have a cultural impact. So defining a multi-criteria value associated to the global impact of the system on its environment requires aggregating these different impacts. This is often done by integrating financial regulation, mostly costs and benefits associated to non-financial impact. For example, we can add carbon taxes or costs associated to the protection measures for the environmental impact while developing the blockchain proof of work. While value provides a measurable impact of this ecosystem and its environment, it cannot fully describe the business ecosystem. Value is not created ex nihilo. It requires an operating system to produce the product of the service. This operating system consists in different interacting components. Each of them is in charge of parts of activities contributed to the value creation. The ecosystem community is organized to support value creation, defining each member's potential role and relationships with partners and competitors. These interactions are managed according to the predefined decision system, integrating decision flows and the way activities and value are shared. Of course, sharing activities and value represent a risk for the different partners. The challenge is to set a win-win organization so that cooperation can benefit from an improved synergy. This involves paying attention to the business context and business development strategy. So, as value creation takes an important part for business ecosystem, let's focus on business environment qualification to capture its impact on the interaction between components of the business ecosystem. Depending on the business and market context, different business strategies can be used, such as competitive strategy, called red ocean, some new industry creating demand strategy, the blue ocean, sustainability strategy, the green ocean, and survival sustainable strategy, the black ocean. Porter introduced the red ocean strategy in 1980. It denotes a highly competitive environment where enterprises have to fight to survive. The red ocean term is introduced to reflect the bloodshed due to the hard fighting conditions. In this case, the market is well known and differentiations or lower costs are key elements to survive. Value is measured with monetary units. Kim and Moban introduced the blue ocean strategy in 2004. It is associated to highly innovative industries, creating new demands on market. In this context, innovation is the key to survive, leading to a high-value product or service creation. Some new industry may be a result of the red ocean necessary differentiation, leading to more and more innovation to create new business opportunities. In such case, the innovative company alters the existing market border and creates a new demand. As in the red ocean, value is mostly considered in monetary units. Purple ocean strategy denotes a mix between the red and blue ocean strategy. It may be seen as a dedicated strategy or as a temporary strategy while defining new innovative processes. Few differentiations create new demand and possibly new parts of the market. Then, according to a longer-term point of view, the market becomes well-known and more competitive. So, we can have the purple ocean either starting from the red ocean by providing more innovation, more differentiation, and then we are going to the blue ocean, or coming back from the blue ocean after a strong innovation when the product is well known and when other competitors join this business ecosystem. The green ocean strategy has been introduced recently, taking into account sustainability and environmental impacts. It takes advantage of both blue and red ocean strategies by exploiting new demands in a green market space, namely paying attention to the environment. It introduced self-competition as a key strategy to pursue continuous improvements. However, it breaks the differentiation low-cost alignments involved in both red and blue ocean strategies to sustainable growth alignment. This is a new way to integrate other criteria in the created value. Lastly, the black ocean strategy consists in closing the market for competitors, namely when high investment must be done with high perceived risks. The temptation consists in closing the market, maybe using unethical means to avoid new competitors to survive. The existing rules are changed so that unfair advantages can be used to survive. How can we close a blockchain system? Is a blockchain innovative, competitive, sustainable, or is it a closed world? Now, we have to decide about the blockchain system. So, after introducing what an ecosystem is and the way it can be characterized, let's come back to our blockchain context. In this section, we will focus on the blockchain key characteristics to fix the ecosystem's key characteristics. As an IT system, the blockchain ecosystem can be considered as a service system. Whatever the blockchain technology is, different parties are involved in a blockchain-based system, each of them adding value depending on the service they provide. As transaction fees are paid using the blockchain token, it leads to build closed ecosystems associated to the different blockchains. Only few actors develop a new business to support token transfer from one blockchain to another. Does it mean that the blockchain is a black ocean strategy? Let's think about it. The blockchain interacts with its environment by providing a service to clients. As in other service systems, the client experience and the value added provided by the blockchain ecosystem are quite different. There are key differentiators to favor its large adoption. Consequently, it requires heavy investment for supporting the infrastructure development, increasing the quality of service and the quality of experience. This new service may also refer to the blue ocean with a totally new innovative product, or a highly competitive environment for developing basic blockchain service. Of course, as other economic systems, a fair balance between investment and return on investment is necessary to have a sustainable organization. If the blockchain is used as a fiat currency, we can know that speculation is at the core of the ecosystem, as payments are made thanks to token. It is the blockchain own currency. This can be a bias for the blockchain ecosystem. As a distributed system, we have to pay attention on the way the ecosystem is structured. Is there any competition or cooperation between parties? Focusing on the core process of the blockchain, as transaction validation relies mostly on competition between the block validators. Miners compete for a proof of work systems, and token of owners compete also for proof of stake systems. Cooperation may occur between these competitors, sharing resources and profits to be able to validate transactions. This is nevertheless mostly done in proof-of-work systems. Whereas the consensus management rule is supposed to manage interaction between block validators, off-chain interactions between parties can occur, either to improve the validation infrastructure or to speculate on the token value. This may change the game, as economic and business strategy is highly dependent of the token pricing. This impacts the usage and the validation. External incentives can also impact the ecosystem organization. Although blockchains are highly distributed systems without taking into account real-world borders, national incentives can also affect the ecosystem organization. These incentives may refer to the blockchain business development. Initial fundraising is based on initial coin offer, and regulation on this initial coin offer depends on the token status and the country. This can be more constrained if the token is a security. We can also pay attention to the legal status of smart contracts depending on the country. This is important in order to promote and develop blockchain usage. Focusing on the physical infrastructure, energy, data centers, subvention to develop sovereign blockchain offers can also affect the ecosystem organization by providing extra support to dedicated actors. Identifying the ecosystem boundaries involves identifying exactly its trading or catchment area. Of course, as the blockchain provides a virtual service, the catchment area is heavily related to the provided service and not to the service provider location. As a disruptive technology, different kinds of customers can also be considered, including final customers, intermediaries providing extra accessibility services, and so on. This impacts totally the catchment area and the blockchain product definition. For permission blockchain, there's a well-known ecosystem perimeter, namely the provided service and the parties involved in the ecosystem are well known. Cooperation agreements are often set between business partners, allowing a mid-term or long-term cooperation, and shared processes may be set. To sum up, the ecosystem boundaries are rather fixed and follow the collaborative business organization own boundary. For permissionless blockchain, the ecosystem is semi-open, leading to more fuzzy boundaries, although the core ecosystem is fixed. Initial core contributors, namely the investors, blockchain developers, and the first set of miners or transaction validators, fix the ecosystem governance rules and the trading area. Then, extra validators can join the ecosystem, provided that they accept the ecosystem rules. Regarding users, they are mostly related to the trading area, and companion usages may emerge, while intermediaries provide extra services on the initial ecosystem. To sum up, there are different kinds of actors in the blockchain ecosystem. First, blockchain developers and block validators are the core of the blockchain ecosystem. Blockchain developers provide the core technology and the core components to support the blockchain activity. Block validators provide the necessary means to integrate new transactions and blocks in the ledger. To support their activity, these actors interact with their environment, and more precisely with infrastructure providers, mostly hardware and cloud providers. But some other actors providing system management tools to optimize the infrastructure can also be concerned and involved in this blockchain ecosystem. Focusing on usages, some end users or new developers may invest to set new services to interact with the blockchain. As such, they can also take an important part in the blockchain ecosystem. Lastly, investors involved in the initial fundraising or bringing extra funds play also a key role in the blockchain ecosystem to support developers and maybe parts of the infrastructure of the blockchain project. In order to identify actors or components of the ecosystem, we can use the Deloitte's multi-layered blockchain service module. This technology stack is based on competencies and is inspired by the IT market. It allows identifying three main types of parties involved in the ecosystem: infrastructure contributors, core platform services, application-oriented services. Globally speaking, the blockchain technology stack is organized into 4 different levels. The infrastructure layer includes both computing resources and mining resources. Basically, transaction validation requires complex and efficient computation. This calls for efficient processors fitting the mathematical computation. It also requires adapted computation software to support parallel computation management, scalable computing resource management, including cloud and network resources, as well as ledger storage facilities. The development of mining as a service involves being able to share federated resources to validate the transaction. While operating on different blockchains, this service requires also a strong coordination for the transaction validation process to optimize the way resources are used. Cooperation between mining providers can also be supported in this mining as a service organization. Network and protocol layer is devoted to the distributed ledger management. This layer is the core of the blockchain technology. It includes the development of blockchain access control to support permission or permissionless blockchain development. Blockchain protection, avoiding perfidious transaction validators, must also be set here. Development related to this layer deal with consensus protocols component to support consistent distributed transaction validation. These protocols are used by lower-level components in charge of the mining process. Token management components refer to the strategy of the token attribution. Next, the blockchain service layer consists in components used to connect the blockchain to other applications or to provide a simple use of blockchain coins. Depending on the blockchain technology and the target usage, it can include different components used to manage the cryptocurrencies on the user side, wallets. It can also integrate authentication, mostly how users can prove their digital identity, how they can manage signature and even multi-signatures, and smart contracts execution by managing events or searching oracles. It also includes components to connect the blockchain to other applications by providing dedicated connectors or managing application servers or distributed database, as well as digital assets management features. The last level, the application layer, is devoted to services, allowing the integration of the blockchain technology in digital systems. It provides a convenient user interface or it improves application integration. Blockchain is a rather new and disruptive technology. It leads to various and dynamic development. From this blockchain ecosystem synthesis provided by Reddit, you can notice that lots of actors are involved in a blockchain project and in the ecosystem based on the target business area. Development strategy is heavily related to the potential market. Paying attention to cryptocurrencies, their development is heavily coupled to fintech and value exchange, so that more and more users can join the ecosystem to interact with the blockchain market. You can see that lots of actors may also interact and may be identified at different parts of the system. After introducing the ecosystem and the blockchain ecosystems, we've just seen that there are multiple actors and it may depend on the target business area. So now, let's focus on the usage-based blockchain ecosystem. We will pay attention to the usage and identify different kinds of blockchain ecosystems. Is there a unique blockchain ecosystem model, or are there multiple independent blockchain ecosystems? What is the blockchain business strategy model? At first, let's qualify the business environment. Even now, blockchain development leads to consider blockchain as a disruptive technology creating a new demand. So we can say that blockchain is related to the blue ocean strategy. Nevertheless, if we consider the blockchain core technology, the mining industry is a very, very competitive one. So this environment adopts the red ocean strategy. There are also different developments on the blockchain. This sounds as a purple ocean differentiation, whereas a non-interoperable market using semi-private blockchain to support distributed applications may be seen as unfair advantages associated to a black ocean strategy. Such a rainbow business environment shows that there are different ecosystems depending on the type of blockchain and depending also on the strategy associated to the target business market. But how can we identify this business market strategy? This refers to the usage rather than to the technology. Identifying ecosystem development based on blockchain usage is heavily related to the blockchain characteristics. It provides trust, immutability, and consensus. In the Truth About Blockchain, a two-dimension classification is proposed to evaluate new blockchain features, the degree of novelty, and the amount of complexity and coordination. Based on these two axes, 4 quadrants are defined. Let's introduce each of them. Single use is associated to less costly and focused solutions such as payments or micropayment. They provide only low novelty. They require low coordination. The blockchain is simply used to certify and store transactions in its distributed ledger instead of paying a trusted party. The localization quadrant is associated to high novelty and reduced coordination, requiring only few users to set the business. Some fintech applications, such as providing a distributed ledger to process transactions, as this is done for the technology used in the Nasdaq, belongs to this quadrant. Substitution means that the new technology replaces another one. It is a low novelty, but it requires a high amount of users. Such applications use the blockchain as a new medium to exchange gift cards, certified diploma, or certified shipment documents. The transformation involves high novelty and high amounts of new users. This quadrant is mostly related to smart contracts. This involves rethinking applications to fit the digital transformation. For example, sharing energy with the neighbors involves new economic model and a large-scale deployment of such smart grid. Other new service model can extend the pay-per-use model to a pay-per-consume one. It can be developed to manage digital rights or ads. Let's now introduce these ecosystems for the different kind of blockchain technology. As stated in the introductory lecture on blockchain background, blockchain 1.0 has been introduced as a Bitcoin. It addresses the fiat currency area. These cryptocurrencies are not interoperable, and the blockchain technology has been introduced as a support for a trusted peer-to-peer currency transfer without any intermediary, except the blockchain. Nevertheless, the blockchain ecosystem is not reduced to the core miners. It also requires wallet managers, merchants, brokers, traders, crypto startups providing cryptocurrency trading apps, as well as long-term investors that are necessary to support the full ecosystem. Blockchain 1.0 has some limits that affect their ecosystems. First, transaction delay makes the blockchain 1.0 hardly scalable. This limit impacts the ecosystem regarding the computing resources required by the potential validators community. Second, cryptocurrency isolation. There's no way to mix different cryptocurrencies such as bitcoins or counterparty coins. This has led to the development of crypto asset brokers and traders so that the crypto asset trading can be improved. Third, the cryptocurrency price expressed in traditional currencies are highly volatile. This is due to the intrinsic organization of the proof-of-work blockchain model, where miners are paid using cryptocurrencies, while they must use traditional currencies to pay for the computational resources and energy. As a consequence, they can speculate on the cryptocurrency to get the best return on their invest. Fourth, fiat currencies are not currencies, as their value is not guaranteed by goods, such as gold or any state income which is related to real valuable goods. They must be considered as tokens, not as currencies. As a consequence, they are not recognized by the different states. Their pricing is heavily dependent on the number of its users. It may change from one place to another, as there is no international regulation. This leads to a competitive fintech ecosystem, where value is mostly related to trading. From this illustration, we can see that the core of the ecosystem is built on exchange platform, valuing the asset transfer from one cryptocurrency to another one. Based on these platforms, trading services such as portfolio management, analytical tools, trading bots, trading exchange services are developed. A key point for such business development is related to the way the catchment area is increased. How can we get a higher number of transactions, and how can we get a higher number of users interacting with the ecosystem? This is driven mostly by the integration of influencers used as marketing development to support this ecosystem. Blockchain 2.0 has introduced smart contracts which couple distributed application and contract-based organizations. Basically, a smart contract is a computerized transaction protocol. As such, the contract execution is fully automatized. The code is publicly stored and operates on the blockchain. It is executed according to the contract terms. As a consequence, a smart contract mixes both technological and legal views. The smart contract execution is associated to events and asset transfer. This may be seen as a link between a token and a valuable service. As in the real contracts, contract terms represent the valuable good or service that must be executed to support the token transfer, so that the transaction payment is included as well in the smart contract. Paying attention to the digital economy organization, smart contracts appear as an event-driven organization that may be opposed to the traditional control flow organization of IT systems. Focusing on the ecosystem, as in the blockchain 1.0, the blockchain 2.0 requires a core of active investors, dedicated infrastructure, and network and protocol services. Similarly, this leads to establish different and non-interoperable systems requiring exchange services. To fit the digital economy development constraints, adapted infrastructure and scaling services must be offered, as well as event management features. Lastly, application layer related tools may be developed to fit specific business areas requirements. In this Ethereum ecosystem illustration provided by Reddit, we can notice that two specific business areas are mentioned. the digital asset management related to the specific non-fungible token part of the ecosystem, and the decentralized finance, DeFi, which includes numerous actors. As in blockchain 1.0, we can notice that the fintech and key fintech actors are very important in the blockchain 2.0 ecosystem. Let's now consider the blockchain 3.0. Blockchain 3.0 has been designed to overcome limits of the blockchain 1.0 and 2.0, such as the lack of scalability, the lack of interoperability, and the lack of sustainability. Lack of scalability means that the delay related to transaction validation do not fit the real-world economic constraints, mostly if the blockchain technology is widely adopted. The lack of interoperability means that blockchains are isolated so that there's no way of sharing transaction data or tokens. It makes harder the authentication process when parts of them are registered transactions in different blockchain systems. Lastly, the energy consumption and the computation costs involved in the public proof-of-concept-based blockchain systems make that this technology can be considered as unsustainable. There are several potential distributed application areas, including fintech, healthcare, gaming, education, as shown by the EOS landscape that is involved in the blockchain 3.0 ecosystem. Now it's time to conclude after identifying the ecosystem and more precisely the blockchain ecosystem and paying attention to the usage-based blockchain ecosystem. In this lecture, we have introduced a basic knowledge to characterize an ecosystem, mostly identify its boundary, key participants, internal structure, and the interaction with the environment. Focusing on the blockchain ecosystem, we have proposed key characteristics to identify ecosystems before presenting usage-based blockchain ecosystems. The blockchain market is a fast-growing one, leading to different ecosystems enactment depending on the technology used. By now, fintech have largely taken advantage of the blockchain 1.0 and 2.0 technology, organizing a decentralized finance area. Nevertheless, the core blockchain technology, with its interesting event-based transaction, can appear as the internet missing element to develop new digital economy support. As shown on this figure, several business areas are addressed by the current blockchain technology, and further works related to blockchain 4.0 adoption, mixing it with the Industry 4.0 context, will also serve the Web 3.0 development. You can find at the end of the lecture notes or on this slide different kinds of resources that have been used to develop this lecture. All internet resources have been tested till fall year 2022. Thanks for attending this CHAISE lecture on blockchain ecosystem. If you want to get in touch, you can use our social media website.